Welcome to TechWide. In this video, we are going to solve problem number 104, maximum depth of binary tree. So here we are given the root of a binary tree and we need to return the maximum depth. Now let's see the logic and the code for this problem. Now let's dive into the solution. So here I have taken an example. So basically we need to find the maximum level we have in the binary tree. So here this is level 1, this is level 2, level 3 and level 4. So here we have 4 levels, right? So we need to return 4. So this is the maximum level from the root node, right? So basically we are going to traverse in the left subtree and the right subtree of my root node. So I'm going to take the maximum depth I have in my left subtree. This is left and this is right. So I'm going to show you guys the intuition right now. So I'm going to traverse in the left side of my root node and then the right side of my root node. So I'm going to do depth first search. I'm going to use DFS here. So whenever I start with a node, I will initialize that node with right and left pointer, right? Then I will move to the left side first of that particular node. I will move from left. So I will traverse the left side first. Then I will move to the right from each and every node. So that here we have a left node. So my new root will be here. My root will moving. Then I will have left pointer and right pointer for this node. So whenever I reach a node, I will initialize left and right pointer to it. So now I need to check, is there any left and right for this particular node? There is no left and right, right? So then I'm going to initialize my left pointer as 0 and right will be 0 as well. Then I will take max of left and right. So the max between left and right here is 0. So I will add 1 to it. I will since the max value, this is max value and this is, we are adding 1 to it. Then this is my new max. This is my max in this node. Now I need to return this max to the previous node. So how I came to this node? I came from the left side of the node 8. So I will, so max is 1 here. I will put this 1 to the left of the node 8, right? That's how here works. Now my root comes here. Now I need to move to the right subtree of the root node. So my root comes to 20. Now I will initialize with left and right pointer. Since we have a left node in this node, so I am moving my root here. I will initialize left and right for this as well. Then I have left. So I'm moving my root here. I will initialize left and right for this node. Now I don't have any other nodes from here, right? We have reached the leaf node. So my left will be 0, my right will be 0. I will take max of left and right. So here the max will be 0 plus 1. So this is my max value, that is 1 in this node. So I will return this 1 to the left of the previous, that is in the node 15. So my node 15 left will be 1 now, right? Now my root comes to the 15. Now I need to go to the right of the 15. There is no node here, so it will be 0. Now I need to take max of left and right. So it will be 1 plus 1. So I need to return 2 to the previous pointer, that is to the left pointer of node 20. So here it becomes 2, right? Now this is my root. Now I have to go to the right side of the node 20. So my root moves here now, and I will initialize left and right to it. Then I need to check whether I have a left pointer. There is no left here, so my left will be 0 to this node. Then I need to check right. There is a node, so I will move my root to the right side. I will initialize left and right to it. Since this is a leaf node, my left will be 0, my right will be 0. So I need to take max of this, that is 0 plus 1. So I'm going to get 1 here. I need to return 1 to the right of the previous, since I came to this node from the right side of this node. So I need to put 1 to the right side, right pointer of the node 7. Now I need to take max of here. So it is going to be 0 and 1, and if I take max of it, I'm going to get 1. Then I'm going to add 1 to it and return. So it will be 2. So I'm going to return to the previous node's right pointer. So it is going to be 2 here. So I'm going to take max of left and right here in this node. It will be 2, then plus 1. I'm going to return 3 to the previous node's right pointer. So here it is 3. Now I need to take max in the root node, that is 1 comma 3. The max is 3 plus 1. So I'm going to return 4 at the end. This is how recursion and the depth first search works. Visually we know here that we have 4 levels. This is level 1, this is level 2, and this is level 3, and this is level 4. So we got the correct answer. Now let's dive into the code. Before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future, and also check out my previous videos and keep supporting guys. So first I'm going to write the base condition that when my root is none, I'm going to return 0. That means when I reach the leaf node, I'm going to return 0. Then I'm going to traverse the left side first of my node. So here I'm traversing left side, right? Then I'm going to traverse the right side. It will be root dot right. So then when I finish that particular root, I'm going to take max of left and right. I'm going to add 1 to it. I think it's fine. Let's run the code. As you guys see, it's pretty much efficient. So guys, I plan to put a recursion explanation video where I'm going to explain how to think recursively. And if you guys want to know about that, please press the bell icon and the subscribe button so that you will get the notifications whenever I upload that video in future. And also check out my previous videos. Keep supporting. Happy learning. Cheers guys.